welcome to the online lecture series. Up to today's lecture, we covered first 2 units of Engineering Mathematics 2. And today we will start unit number 3. In that there are 4 different types of integrations. Today we will cover reduction formulae, why we need the reduction formulae of some integration, and how to reduce in a simpler manner. So let's start. The unit number 3, integral calculus. In that we will see what is meant by the reduction formula. So first we know why we required the reduction formula. For that we will just see a simple integration. Here we have to find the integration of your sine function. And we know the solution of your sine, means integration of your sine is simply minus times cos x. The solution of your sine integration is minus times cos x, and plus c is the constant of integration. It means it's very easy to find the integration of your sine by using the first principle of the derivative. When we say what happens when I just increase the index of your sine function, in case number first or example number first, the index of your sine is 1. In example number 2, when I change the index of your sine as a 2, then how to find the solution of your sine square x? We can find the integration of your sine square x by converting your sine square in terms of your 1 minus cos 2x upon 2, the formula of your sine square, and separating the terms, that is a 1 by 2 and minus cos 2x upon 2, and finding its integration. We know that the integration of your 1 upon 2, it is a constant for integration. So we are making the separate integration to find the solution. Then the integration of your 1 by 2 is simply x, and integration of your cos 2x upon 2, it becomes sin 2x upon 4, because the divided by terms of your cos 2x is 2. What happens? Suppose I increase the index of this sine to 3, 4, 5, 6, 7. Then how to find the solution? So in general, when I say that if the index of your sine is suppose n, and the integration of your integration whose limit ranges from 0 to pi by 2, and n is the index of this sine function and whose value is greater than 0. In such case, how to find the simpler way to find the integration of such a function whose index is greater than suppose 2. So instead of saying 2, instead of saying n is greater than 0, we said that n is greater than 2. For 2, 3, 4, 5, 6, 7, how to find the solution? For that, we have to make the reduction formula for such integration. So we observe here the index of your sine is n, so we denoted this integration as a I of n. Why? Because the index of your sine function is n. The index of your sine function is n, so we denoted this integration I suffix n, means in is sine raised to n x dx. Suppose I change the index of your sine. Suppose here index, suppose instead of n, it is 8. So we denoted this particular term as I suffix 8. So the index of your sine denotes the integration with I suffix that number. So we get the value of your in this particular function is integration sine n x dx, means the index of your sine is n. We eliminate the integration limit to find the reduction formula. So in this case, we have to split the index of your sine in such a way that one function integration can be calculated very easily. For that, we can reduce the index of your sine, that is n, in terms of sine of whose index is n minus 1 and x. We splitted the index of your sine. So we say that this n can be replaced, n is equal to n minus 1 plus 1, it's my value of your n. So the index of your sine does not affect in this particular reduction or in this particular separation. So sine x is my first function and sine raised to n minus 1 of x is my second function. So we have to use the by parts here to find the integration, and we know the formula of your by parts. If u and v are the functions of x and we have to find the integration, the formula of your by parts is we have to keep u as it is, taking the integration of your v with respect to x, derivative of your u with respect to x, multiplied by integration of your v with respect to x, and whole terms integration with respect to x is the general formula of your by parts. So using the by parts, your value of your u is equal to, we said that u is equal to here sine raised to n minus 1 of x. So we say, we will write here u is equal to this, and v is equal to sine of x. So we got two functions. So we have to simply replace the value for u and v in this by parts formula to find the integration of such terms. In the next step, we will take the integration by using the by parts. So here the u remains as it is, we are keeping u as it is, and integration of your sine is minus cos x minus, and here integration, we have to find the derivative of your sine raised to n minus 1 of x. How to find the derivative of such function? We can find the derivative. So here du divided by dx can be calculated. We have to find the derivative of this particular function. Derivative of this function, and it can be find by using the formula, that is x raised to n. So index of your sine is n minus 1, so n minus 1 sine index reduced by 1, it becomes n minus 2, and again we have to find the derivative of your sine function. We have to find this n minus 1 here, we write it here, n minus 1, index of your sine reduced to 1, and the derivative of your sine x is cos x. It's a simple derivative of your sine raised to n minus 1 x dx. And again, the integration of your v with respect to x, the integration of your v with respect to x becomes minus cos x into dx. So we get this particular solution. In the step number, in the first term, we have to just take minus n as a common. So we get minus 1 minus sine raised to n minus 1 x cos x. The n minus 1 is a constant which are taken outside your integration. Again, the sine whose power is n minus 2 of x, and cos x, and this minus cos x becomes cos square, and minus sign just taken outside the integration, it becomes plus. So this is the formula of the reduction. Again, we have to just use the formula of your cos square. The cos square is nothing but your 1 minus sine square. This sine raised to n minus 2 is multiplied to this bracket 1 minus sine square x. We got the integration sine raised to n minus 2 x. First terms remains as it is. N minus 1 remains as it is, plus 1 remains as it is. This sine into 1 becomes sine raised to n minus 2 into x. And again, sine raised to n minus 2 x into sine raised to 2 x becomes sine raised to n of x dx. And making the separate terms of this, we are making the separation. According to assumption, this particular terms becomes I of n minus 2 and this becomes I of n. So we have to reduce in terms of n. So we got In is equal to minus sine whose index is n minus 1 of x cos x plus n minus 1 of I of n minus 2. Because here the index of your sine is n minus 2. So it can be expressed into of I of n minus 2. The last integration, the index of your sine is n. So it becomes I of n. So the I of n is shifted to your left hand side, and by making the simplification, we get the standard reduction formula for your sine function. So in get cancelled, this n times I of n remains here. We are making the simplification on left hand side, the right hand side remains as it is. And this is the value of your n times in. But we required in, so n is multiplied to in, divide entire equation by n. So we got reduction formula of sine whose index is n. In is equal to minus sine raised to n minus 1 x cos x upon n plus n minus 1 upon n I of n minus 2 is the reduction formula for only the sine whose index is n, and limit of your integration is nothing. But we required the reduction formula for the sine raised to n of x dx, whose integration's limit goes from 0 to pi by 2. So first we have to assume the given particular integration is equal to in, and we already find out the value for integration of your sine raised to n x dx. So we have to put the upper and lower limit in that only. This is the reduction formula in which the variable x is present. So we have to just change, put the upper and lower limit in these particular terms. And we know that the upper limit minus lower limit is the formula for replacing your upper and lower limit. So here we got 1 upon n is outside here that particular bracket. Sine raised to n minus 1 pi by 2 cos pi by 2. Again minus times, replacing the value for lower limit and remaining terms as it is. And we know that sine pi by 2 is equal to 1, cos pi by 2 is equal to 0. So first particular terms become 0. And in second, sine 0 is equal to 0. The entire terms become 0. So we got reduction formula for the sine in terms of n minus 2. So this is the one case in which we get in terms of I of n minus 2. Let's observe here the suffix of your I is n, and the ratio is started from your n and reduced by your n minus 1, and the suffix of your I becomes n minus 2, means n minus 1, n minus 2, means there is a relation between your n. To find the value of your I of n minus 2, when I replace the value of your n is equal to n minus 2 in the equation number A, what we got? We can say that the value of your in becomes I of n minus 2, and replacing your n is equal to I of n minus 2. Then n becomes n minus 2 minus 1 divided by n minus 2. I of n minus 2 minus 2 becomes minus 4. So I will mention here I minus 2. So n minus 2 minus 1 becomes n minus 3 divided by n minus 2. And I of n minus 4. So again, we have to find I of n minus 4. In a similar way, we can find putting the value of your n is equal to n minus 4 in equation number A. And we get I of n minus 4 is equal to n minus 5 divided by n minus 4 into I of n minus 6. In similar way, we can find all the values. Means it reduced to I0 or I1. This is the value for my I6. I6 equal to this. In similar way, we can make the calculation to up to we get value for I2. To find the value for I2 means we have to just proceed this and so on, means there is no end. We get I suffix 2 or I suffix 1. For finding the value for I of 2, we have to replace the value for n is equal to 2. We get I2 is equal to 1 by 2 I0. And we have to find the I0. If n is even, then last term is this. And if n is my odd, then my last term is I1. To find the value for I0, we have to just replace the index n equal to 0. Sine 0 of x dx is nothing but my sine x bracket is to 0. Means we get only dx. And integration of your dx is nothing but x. And replacing upper lower limit, we get pi by 2 minus 0 equal to simply pi by 2. When value of n is odd, we get last as 1. To find I1, we have to replace the value of n is equal to 1 in this. And we know that the integration of your sine is nothing but minus cos. Replacing your upper lower limit, minus cos pi is 0 and cos 0 is my 1. So we get reduction formula for such a this by combining all the results. So In is equal to integration runs from 0 to pi by 2 sine raised to n x dx is equal to n denominator n, numerator n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7 up to 1 by 2 and lastly pi by 2 if the value of your n is even. If the value of your n is odd, we get a second reduction formula for sine whose integration runs from 0 to pi by 2. In a similar way, we can find the value of your reduction formula for your cos. By similar manner, we have to assume the first term is equal to In. Then we have to split the index of your cos such that one function's integration we know. So we splitted the index of your cos in n minus 1 and cos. Then taking the integration by using by parts formula. Then replacing u and v in this, we get this. This is the derivative. And integration of your cos is sin x. Again, sine becomes sine square minus n outside integration. So In becomes cos raised to n minus 1x sin x. Minus become plus. Cos raised to n minus 2x sin square. Again, we have to replace the value for sin square. Sin square is nothing but your 1 minus cos square x. We replaced here. And similarly, multiplying this cos raised to n minus 2 into the inner bracket. So we get In is equal to cos raised to n minus 1 of x sine x plus n minus 1 integration cos raised to n minus 2 x minus, making the separate integration. This whole terms becomes I of n minus 2. This terms becomes I of n minus 2. This term becomes I of n. So we can write this in is equal to, again in shifted to your left hand side. Making the simple calculation on your left hand side, we get this step. In get cancelled. Again, the same reduction formula for your cos function. And to find the value of your in when the limit goes from 0 to pi by 2, we have to again just put the value of your limit, upper and lower limit in the reduction formula. So after replacing your upper and lower limit, we got the formula for your in is n minus 1 upon n I of n minus 2. In similar way as that of your sine, we have to put the n is equal to n minus 2, n minus 4, and so on. We can find the value of your reduction formula for your cosine function. We have to use the same manner here. Putting n is equal to n minus 2, n is equal to n minus 4. We are put it here, n is equal to n minus 2. So we say that n minus 2 is equal to this. Similarly, we are putting n is equal to n minus 4. We got I4, I of n minus 4, n minus 5, n minus 4, I of n minus 6. And in similar way, we will just calculate I of n minus 6, replacing the value of your n is equal to n minus 6 and so on. We can find all the values. Lastly, we have to either find I2 or I1. To find I2, we have to replace n is equal to 2. So I2, 1 by 2, I0. To find I0, replace n equal to 0 in your given formula or in your given integration. So we get the final answer for I0, pi by 2. If n is my odd, I get I1. To find the value for I1, replace the value for n is equal to 1 in your this. For combining this result, we get in is equal to integration 0 to pi by 2 cos raised to n of x dx, n minus 1 upon n minus 3 upon n minus 2, n minus 5 upon n minus 4, up to 3 by 4, 1 by 2, pi by 2, if n is my even. For odd, it is again up to 4 upon 5, 2 upon 3, up to 1. So by using the above reduction formula, we can find the solution for some standard example. The integration of your this particular sine whose index is at x dx, limit goes from 0 to pi by 2. When we compare this, here n is equal to 8 and 8 is my even. And we know that for the even, the formula is this. We simply replace the value for n is equal to 8. Means the equation, the solution becomes 7 by 8, 5 by 6, 3 by 4, 1 by 2, 1 pi by 2. After making the calculation, I get a final solution 105 pi upon 768. In a similar manner, if within f n is 6, we have to replace 6, 5, 4, 3, 2, 1 pi by 2. This is the solution. For 7, if it is odd, we just replace the value for n is equal to odd. The numerator containing all even numbers, the denominator containing all odd numbers. If my n is odd, if my n is even, all the values of your numerator are even. Sorry, odd. The denominators are even. In this way, we can find the value of your any index of your sine and cosine, which is in the form of integers. The last example is here, the sine raised to 9x. We have to replace the n is equal to 9 in this, and we get a final solution. Thank you.